Your password is not stored anywhere. Not on the website. Not in the database. Not even at your bank. What's stored is a hash. A scrambled fingerprint of your password. And in this episode, we take those hashes and turn them back into real passwords. Hashcat, John the Ripper, and Hydra. Let's crack. Quick disclaimer first. Everything here runs against hashes and accounts that you own, a lab you built yourself, or a system you have written permission to test. Cracking someone else's credentials is a crime. We study the attack so we can defend against it. Authorized targets only, every single time. So what actually is a hash? When you set a password, the system runs it through a one-way function. Feed in your password, and out comes a fixed-length string of gibberish. The same input always produces the same output. But there is no reverse gear. You cannot unhash a hash back into the password. That is the entire point. So how do we crack it? We guess. We take a candidate password, hash it with the exact same algorithm, and compare. If our hash matches the stored hash, we have found the password. That's it. Cracking is just guessing at an enormous scale. Billions of guesses per second, until one of them lines up. But first, you have to know what you're dealing with. An MD5 hash is 32 hex characters. NTLM, from Windows, looks almost identical. A bcrypt hash starts with $2B. SHA-256 is 64 characters long. Guess the algorithm wrong, and every crack attempt fails silently, forever. Tools like hash ID and hash identifier take a hash and tell you the likely format. Hashcat even ships example hashes for every mode, with the example hashes flag. Identify first, crack second. Getting that mode number right is half the battle. The rest is horsepower. Now the heavy hitter. Hashcat. It is the fastest password cracker on the planet, and it runs on your graphics card. A modern GPU chews through billions of MD5 guesses every second. The core command is simple. Hashcat, -m for the hash mode, -0 for a word list attack, then your hash file and a word list. And the word list that started it all is rockyou.txt, 14 million real passwords, leaked in a breach back in 2009, and shipped right inside Kali Linux. An uncomfortable number of people's passwords are on that list. Point Hashcat at rockyou, and weak passwords fall in seconds. When the raw word list is not enough, you add rules. A rule mutates each word. Capitalize it. Append a year. Swap letters for lookalike numbers. Add an exclamation mark on the end. Password becomes capital P, 4, SS, 0, RD, exclamation. One rule file turns 14 million words into billions of realistic variations. John the Ripper is Hashcat's older, CPU-friendly cousin, and it is brilliant with Linux hashes. First you combine the password file and the shadow file, using unshadow, into a single crackable file. Then John, pointed at a word list, goes to work. John auto-detects most hash formats for you, which is a real-time saver. John has 3 modes worth knowing. Single mode uses the username and account details as clues, because people really do use their own name as their password. Word list mode runs a dictionary. And incremental mode is pure brute force. Every possible combination. The slow, last resort option. Type John --show to reveal what you have already cracked. Everything so far has been offline. You already had the hash in hand. Hydra is a different animal. Hydra attacks the login itself, live, over the network. It hammers a running service. SSH, FTP, a web login form. Trying username and password combinations as fast as the service will answer. The command names the target, the service, a login, and a password list. Hydra, lowercase l for the login name, uppercase P for the password file, then SSH, // the target address. But online cracking is loud. It floods the logs, trips account lockouts, and is trivial to detect. It is a lab and last resort tool, never a stealthy one. So how do you beat every tool in this video? Length. A cracker's worst enemy is a long, random, unique password. Add just one more word, and you multiply the number of guesses by thousands. A 4-word passphrase already outlasts a serious cracking rig. Length beats complexity, every single time. You can't remember 100 long random passwords, so don't even try. Use a password manager. Bitwarden, free and open source, generates and stores a unique password for every account you have. Then one leaked site can no longer unlock the rest of your life. And turn on 2-factor authentication everywhere it is offered. And if you build systems, this part is on you. Never store passwords in plain text, or in bare MD5. Use a slow, salted algorithm designed for passwords. bcrypt, scrypt, or argon2. A unique salt for each user destroys pre-computed rainbow tables. Rate limit your logins, and lock accounts after repeated failures. That is what stops Hydra cold. Let's recap. Passwords become hashes. Hashcat and John crack those hashes offline, at staggering speed, using word lists like rockyou and mutation rules. Hydra attacks live logins online. And every one of them is defeated by the same things. Length, uniqueness, a password manager, and slow, salted hashing on the server side. This is core OSCP, PNPT, and CEH material. Professionals do exactly this, on authorized engagements, against systems they are paid and permitted to test. The skill is not the crime. Doing it without permission is the crime. Written authorization, defined scope. Always. Your lab exercise. Pull a few hashes from your own test machine, identify them with hash ID, then crack them using Hashcat and John with the rockyou wordlist. After that, spin up a throwaway SSH box and run Hydra against your own account. Next episode, we take a cracked login and escalate. User to root. User to system. Privilege escalation. Subscribe so you don't miss it.